Welcome to Lesson 6. Everything is built. Let us run it end to end and read what comes out. 3 commands. Seed the database, run the job, send in the agent. First, seed. 678 rows across 30 days, 40 of them from yesterday, and 16 values that will not convert to a number. That last line is the fault we planted, reported by the seed itself, so you can see it went in. Second, run the job, and it fails, exactly as designed. Integrity error, cannot store text value in real column orders.amount. Read that carefully, because everything about this project comes down to what that message does and does not tell you. It tells you the column. It does not tell you which rows, how many of them, what they have in common, or when it started. A person on call at 7 in the morning has a column name and nothing else. The job also wrote the handoff file and exited with code 1, so the scheduler knows it failed. Third command, send the agent in. Here is the trace, and this is the part worth watching, because you can see it, thinking in the order a good analyst would. It lists the tables. It describes both of them, so it knows one is strict and one is not. Then it calls find uncastable values and gets 16 rows across 8 distinct values. Then bad value breakdown across city, channel, status, and product, and then again without product, which is it testing whether product was incidental. 9 tool calls in this particular run. Yours will not be identical, because the model picks its own queries, and mine have landed anywhere between 9 and 12. And here is what it wrote. 2 faults, not 1. Fault 1, 9 rows, city equals Pune, and channel equals point of sale, and status equals refunded, with the amount coming through as N/A. Fault 2, 7 rows, channel equals marketplace, where the amounts arrived with thousands separators in them. First seen, the 9th of August. Nothing before that date. That single line is the most useful thing in the report, because it turns this from a data problem into a question you can go and ask somebody. What changed yesterday? And then the part I care about most. What was ruled out? Not all refunded rows are bad, because refunds in other cities load fine. Not all Pune rows are bad, because Pune orders that were not refunded load fine. It checked the control groups we planted in Lesson 2, and it did not fall for either of the obvious wrong answers. The find SQL uses column conditions rather than a hard-coded list of bad values, which means you can still run it tomorrow when the bad values are different ones. Total cost, about 1 cent. Now, one honest note about models, because this is a real part of the engineering. I first built this on GPT-4o Mini, and it could not do this job even with all 6 tools. It mixed up the row counts, it put an incidental column in the pattern, and once it answered in prose without calling the final tool at all. Everything you just watched is GPT-5 Mini. The gap between those 2 models on this task is worth about 1 cent per run. So, what you have now is 3 steps. Your company's real questions as SQL, a schedule so they run without you, and an agent that investigates when they break. That is not a portfolio project. That is a small piece of production data engineering, and almost nobody applying for the same job as you has one. The whole thing is on GitHub. The README has every command in it, and your key stays in .env where it belongs. Go and point it at your own data. Thank you for watching.